Dear students, in this video I will discuss about the theory questions of retaining wall and earth pressure. It is in the curriculum of Mumbai University Semester 7 Architecture students. The subject name is Theory of Structure 7. So let us have a look at the questions. Here I will discuss about how to write typically the answer in the exam to get the full marks. For detailed knowledge, you can refer to any book, any standard textbook available in the market. So let us have a look at the first question, that what is a retaining wall? Retaining walls are used to retain, from here the name comes, retaining. So retaining walls are used to retain or hold the pressure of the soil mass or the earth material. The material retained or supported by a retaining wall is called backfill. The position of the backfill lying above the horizontal plane at the elevation of the top of a wall is called surcharge. The backfill saturated with water is called submerged backfill. Retaining walls are in the construction of the basements below ground level, wing walls of bridge, and to retain slopes in hilly terrain roads. The terminology over here, backfill, surcharge, submerged backfill, these terms will be used when we will solve the numerical of the retaining wall and the earth pressure. Next question is, what is a gravity retaining wall? A gravity retaining wall is the one in which the required stability against the thrust exerted by the backfill, including surcharge, if any, that means there may be surcharge, there may not be surcharge, that is resisted by the dead weight of the wall, that is the dead load of the retaining wall, which is either made of brick masonry, stone masonry, or plain cement concrete. The size of the wall is so kept that there is no tensile stress developed at any section of the wall under any condition of loading. Here I have shown three different types of the gravity retaining wall. Next is, what is cantilever retaining wall? The most common and widely used retaining wall is of cantilever type. This is the most common type, okay? And this is economical up to 6 to 7 meter height, moderate height it is called. This cantilever retaining wall consists of three components: number 1 stem, number 2 toe, and number 3 is the heel. Each of these components are designed as a cantilever. That's why the name comes as the cantilever retaining wall. Now, vertical stem resisting earth pressure at one side and the slab bends like a cantilever. The thickness of the vertical slab is large at the bottom and decreases towards the top. So it is a tapering shape. From the top towards the bottom, it is a taper shape, or the shape of a trapezium it takes. So the stability of this wall is partially provided by the weight of the earth on the heel. Many times, to increase the resistance of the wall to sliding, it becomes necessary to provide a vertical projection known as key below the base of the wall. Next is, what is a counterfort retaining wall? Counterfort retaining walls are economical up to height exceeding 5 meters of earth fill. In this type of wall, the base slab as well as the stem of the wall span horizontally as continuous slab supported on counterfort. Counterforts are the vertical brackets. The more the height of the wall, the closer should be the spacing of the counterfort. The counterforts take reactions from both from the stem as well as the heel slab. What is buttressed wall? The buttressed wall is identical to a counterfort retaining wall, with the main difference that the vertical brackets are provided in front of the wall, that is on the face opposite to the face retaining backfill. The brackets in this case are known as buttresses, and by virtue of their location they are subjected to compressive forces only. Now next I am starting with the different type of earth pressure. So it starts with the Rankine theory of earth pressure. So what are the assumptions on the of the Rankine theory of earth pressure, or the question may come as write short notes about Rankine theory of earth pressure. So first you write down that Rankine's theory is used to calculate the soil pressure. It is based on the assumptions that the soil it is retaining, that is dry and cohesionless. Number 2, there is no friction between the soil and the retaining wall. Number 3, retaining wall is allowed to move away from the soil by sufficient amount so that the soil expands and evokes full shearing resistance and attains a state of plastic equilibrium. Next question, it is very important from the structural point of view, that is what are the forces that are acting on a retaining wall. Number 1, lateral earth pressure due to the backfill. Number 2, vertical forces including the weight of the soil, stem, heel, toe and soil fill above the toe. Number 3, the soil pressure developed to resist the earth pressure and other vertical forces acting on the heel and toe. Next is how many types of earth pressure are there. There are 3 types of earth pressure. Number 1, earth pressure at rest. Number 2, active earth pressure. Number 3, passive earth pressure. So this is one question, maybe it can be asked for 2 marks. Now next question is about that discuss the earth pressure about rest, at rest. So these part are very important for you to understand the topic, as well as when we will go to the numerical part. So there also it will be helpful. First of all, I have shown the diagram at the right hand side, that is about the earth pressure at rest. In this case, the retaining wall is stationary. There is no yielding of soil. Number 2, elastic equilibrium exists. Number 3, theory of elasticity is used. Number 4, coefficient of earth pressure at rest. It is very, very important. That is denoted as K subscript O. That is equal to mu divided by 1 minus mu. Here mu is the Poisson's ratio. Now next question, it is very important. You can expect this question, that how you should write it, and based on this concept, that is the active earth pressure and the passive earth pressure, we are going to solve the numericals also. So what is the active earth pressure and passive earth pressure, or write down the difference between these two earth pressure. So let us have a look. In case of a active earth pressure, the soil exerts a push against the wall. Soil exerts a push against the wall, so the wall starts moving away from the backfill. You remember it like this way, because active earth pressure, active means starts with A, and it is moving away from the backfill, because sometimes we are confused that active and passive, which one, in which case the backfill is moving towards the wall and in which case the backfill is moving away from the wall. So in this case, in case of a active, the backfill is the wall to move slightly away from the backfill, and this kind of pressure is also known as the AEP, that is the abbreviation. I am reading out or explaining you about the active earth pressure. So the next point comes that the soil yields due to stretching. Stretching means pulling, that is means tension. Okay, the soil yields due to the stretching or the tension. Number 3, coefficient of active earth pressure, that is K subscript small a. This is universal notation, so please keep it in mind. So Ka is equal to 1 minus sin phi divided by 1 plus sin phi. Here phi is called the angle of friction. And in the diagram also I have shown it, that the retaining wall, I have shown it initial position with the blue color, and the soil mass it is retaining also. But in case of a active earth pressure, by showing the arrows, I have explained that how it is moving away from the backfill. Now let us have a look at the passive earth pressure. So the pressure or the resistance in which soil develops in response to the movement of the structure towards the retaining wall, it is called as the passive earth pressure. Here the soil yields due to shrinking. Shrinking means compression. And coefficient of earth pressure K small p subscript p is equal to 1 plus sin phi divided by 1 minus sin phi. Here phi is equal to angle of friction. So here also in the diagram I have shown it by the arrow that how in this case the backfill is moving towards the structure. So by this way an individual short note can also come, or the question can be formed as I have shown here, that write the difference between active and the passive earth pressure. Next question is that please write down the stability conditions to be checked for the retaining wall. So this is also very important. First of all, the wall should be stable against sliding. That means that when the wall is unsafe in sliding, in that case you should provide shear key just below the stem. I have shown it in the diagram also a few minutes before. So, and the second point is the wall should be stable against overturning also. Overturning or the toppling. And number 3 is the wall should be stable against bearing capacity failure. So these are the 3 stability conditions we have to check for the retaining wall. Minimum factor of safety for the stability of a retaining wall is, please write it down. So number 1, for against sliding it is 1.5, against overturning it is 1.5 to 2, against bearing capacity it is 1.5 to 2. So here I complete the theory portion or the basic concept about the retaining wall and the earth pressure. Please see my other 2 videos on the specifically speaking there are other 3 videos. In one video I have discussed about the proportioning or the design proportioning of the cantilever retaining wall. In another video I have decided about I have discussed about the proportioning of a counterfort retaining wall, and in another video I have discussed about the different type of earth pressures and the different 4 or 5 cases, that if there is surcharge, if there is no surcharge, so different 5 or 6 cases I have discussed over there. So please see the other 3 videos on this topic, and if you like my video please share it, and you can put your comment in the comment box, or any query you can email me at the given email ID. Thanks for watching.